All right, so last conic section that we're going to take a look at today. We talked about parabolas, and those, again, all week long we've been kind of talking about this idea from kind of an engineering type of standpoint of where could you go through and what things are created using these concepts. We talked about parabolas and the idea of flashlights, and that the light bulb is like the focal point, and then the parabola is the reflection, and that's where the light is coming from. We talked about different ellipses and orbits and all that kind of stuff. Today we are going to talk about a hyperbola. And if you take a look at, this is kind of the cooling tower of a power plant. A hyperbola is basically, to give you kind of a general idea, if you take your ellipse that we were talking about yesterday, and you cut it right down the middle and pull it apart, and then take everything and flip it the opposite direction, that's what a hyperbola looks like. Okay? So the focal points that you had in there before that were facing each other, which created the ellipse, now you're basically flipping it, and it's facing the opposite direction. So if you look at this picture, you can kind of see that this curve right here, there's one parabola kind of facing that direction. Here's another curve right there. This was built, those curves are basically hyperbolic curves, okay? Hyperbolas, in order to build that. Okay, so that's one place where you could see that. Here's as we go through and we get into some information. Definition of a hyperbola. As we take a look, we said a parabola, number one thing, the definition was that the distance to the focal point and the directrix were always the same, regardless of which point you chose on a parabola. Yesterday, we said on an ellipse, every point, the distance from each focal point to any point on the ellipse, those two distances, the sum was always the same. The only difference today is it's the difference of those two, those same exact ones. It's now the difference is always a constant. Okay? And so if you take a look, here's kind of what a hyperbola looks like. Here's the general idea, like I was telling you, it's basically like two parabolas facing opposite directions. Where you can see point A in this picture is one focal point. Point B in this picture is the other focal point. Okay? One where, again, the parabolas are kind of wrapping around those foci, is the idea. And if you notice, and actually let me go into this a little bit. Here's that same, oops, don't want that. And this guy's going to come wave. Yep, let's get rid of him. All right. And so now, as we take a look, notice the distances they're talking about from point A to point P, from point B to point P. Again, from the foci to a point on the hyperbola, the difference of those two lengths. Right now, if you notice it's at 2.0, that is a constant difference. Well, if we take a look as I move this around, you can see the distances are changing, but the difference between those two is not. That is one of the properties, again, when you go through and you deal with some of the engineering side of things. That's one of the properties that you have within a hyperbola. And we talked about some of the applications here, some real-life applications. Hyperbolas are used cooling towers, like I said, just the shape of them. Shadows, if you think about a lampshade at home, comes out the top, comes out the bottom of the lampshade. Well, what appears from each part happens to be a hyperbola as well. Radars, microphones, again, all the technology that goes into that is hyperbolic, is the idea. Okay, so without getting too much in depth on that, the technology there is a hyperbola. So here's the general equation. Here's the main ideas for today of, all right, what does the equation look like? What are the kind of the nuts and bolts of things? If we take a look, equation look familiar? What's the only difference? There's a minus instead of a plus. That is the only difference in the equation. And what I mentioned it before when we were talking about the assignment. So parabolas only have one squared term. Ellipses have two squared terms, but they're both the same side. They're either both positive or both negative. Hyperbolas have two squared terms, but one is positive and one is negative. That's, as you're looking at equations, and that's what we're going to do tomorrow. I'm going to give you a little bit of practice on all of it and try to determine how do I know whether this is a parabola versus an ellipse versus a hyperbola. It comes down to how many squared terms and what's the sign on those. Okay? So yesterday we talked about the major axis and the minor axis and which way it was stretched, and trying to figure out which one is A, which one is B. Well, when we take a look today, when we start talking about graphing those parabolas, the actual hyperbolic curves, if you will, how do we know whether they're opening up and down or whether they're opening right or left? Comes down to one main thing. Whichever term is the positive one. So in this case, notice this is the positive term. Therefore, that's where the a squared is located. A squared is always with the positive term. Same thing over there. If you notice here, the y term is the positive term. Therefore, a squared is the positive one. Okay? So since this is horizontal, since you're dealing with the x's, that's why it's right and left. Okay? That's why it's opening horizontally. Since the y squareds here are the positive term, that's why this is up and down. That's why they're vertical. Okay? Does that make sense to you? So the positive term will always determine the direction of the two hyperbolic curves. Okay. A lot of the other stuff is still the same. There's still a center that we're going to work off of with a hyperbola, just like with an ellipse. Okay, so that's still the same. The vertex, as we try to figure out where are the actual parabolas, it's still the center point plus a, just like it was yesterday when you were doing the hyperbola or the ellipses. That's still the same. Foci are still the same. Center point plus c. That'll get you to where the focal points are located. Okay, so that's all the same. So far, it's that one difference. Here's the only other difference. Notice now, in order to find c, in order to find that distance to the foci, it's now a squared plus b squared. When I was talking about before, when it was a squared minus b squared in the assignment, the minus made sure that you came back and those foci were inside of the ellipse. Now when you flip the ellipse each way, by adding the b squared, it makes sure that the foci are on the other side now. Okay, it's moving them further out. Okay, or further up and down, one of those two, so that they're inside of the parabolas. That's why you're adding the b squared instead of subtracting at this point. Okay? One other thing, maybe you noticed it, maybe you didn't, I didn't mention it, but maybe you noticed it when you looked at the graph. There are asymptotes here in terms to try to guide you in terms of where to not only do which direction is the parabola opening, but how wide is it, how narrow is it, that kind of stuff. Well, there's asymptotes that we're going to deal with. We're not going to go too in depth on this, but there's something called a fundamental rectangle that we're going to use. Basically, we're going to use A and B to create a rectangle. And the asymptotes always go through the diagonally. They just go right through the corners of that rectangle. Okay? And so that's what we're going to create as we work our way through it. So, with that being said, let's try one. Okay? Really, the only difference is the graphing. The process is exactly the same in order to get it into the form. The graphing is the only part that's different. Okay? What's that? So here's what we're going to do. Okay? Example number 1 here. We got to complete the square. We got to work our way through it. We got to find, again, those same 5 points. H, K, and then A, B, and C. So let's start with the X's. Okay? First off, notice we have, first thing I want you to notice, 2 squared terms. Means this is not a parabola. It's got to either be an ellipse or a hyperbola. Why is this a hyperbola? The signs are different. One's positive, one's negative. If that was a plus sign in front of the 3, this would be an ellipse. Okay? So again, that's how you kind of tell the difference. So in order to complete the square on the x's, I'm going to factor out a 4. So that's where we're going to start. Take the 4 out. That leaves us with x squared plus 2x, and then plus 1 to complete the square on the x's. What about the y's? Don't overthink this one. We don't even need to take out anything. There's no other y to complete the square, so we're not going to complete the square with the y's. You got to have a y squared and a y. You got to have an x squared and an x in order to complete the square. You always are trying to end up with a trinomial. If you don't have another y to work with, for now, just leave it alone. You'll see what happens. Okay? So we're just going to write this as minus 3y squared. And as usual, we're going to take the constant, move it to the other side. So subtract 16. What do I add to the other side in order to keep this balanced? Yeah. We completed the square with a 1, but then you got to multiply it by the 4 that you factored out. So ultimately, we add 4 to the other side to balance that equation. Okay. All right, let's clean it up. As we work our way through this, we have 4 times the quantity x plus 1 squared. Again, I'm going to leave it right now as minus 3y squared. And then equal to negative 12. Now, same thing, same equation, we got to get it equal to 1. So now I divide everything by negative 12. Okay? Divide everything by negative 12. Which means, in this first problem, I'm going to put the negative on the top. Not that it matters, you can put it out front too. X plus 1 squared. 4 goes into 12 3 times, so we end up with a 3 in the denominator. When I divide this by negative 12, we end up with a plus y squared over 4, and then equal to 1. There is your equation for your hyperbola that you're going to get all of that information out of. Okay. So notice, what I'm hoping you're noticing is this process, it's the same. It's exactly the same as what we did yesterday. Nothing has changed except for a sign, one sign. Now, as we take a look, let's start with h and k, because that's, again, where we got to start everything. What are h and k on this one? What's the center of this hyperbola? What is it? It's not 1. Negative 1 and 0. So in this case, that's why it was okay that I didn't have to complete the square, because there was no, I didn't have to move the y coordinate. It's a y coordinate of 0. So your center point is at negative 1, 0. So we'll put that on the graph. There it is right there. Okay? Negative 1, 0. That is the center of my hyperbola. First question on this one. Is this hyperbola going to open up and down or left and right? Why up and down, Alex?
Y squared denominator is bigger.
It's not because of that, although it turns out that that also is true. That's the positive term. You're looking for which term is positive. The positive term is the direction that it's going to open. Since the y's are positive, it's going to open up and down. Okay? Which means, now going to kind of what you were talking about, which means the 4 is the a squared. The a squared is always on the positive term. Okay? Which means a is what? 2. So that means from that point that we plotted, our center, we are going to go up 2 and down 2. Up and down again because that's the direction of our hyperbola. What is b? It's the square root of 3. Yeah. This is b squared. Okay, 3 is b squared, which means the square root of that is your actual b value. So b is the square root of 3, which is approximately 1.73. Okay? So that way, as you try to graph it, kind of gives you an idea what's going on. So if we go in the other direction, approximately 1.73 each direction. We'll go to about here, and we'll go to about here. All right, so here's the point where I told you that we're going to create that fundamental rectangle. That's what those 4 points are on the outside are going to do. This is the top of the rectangle, bottom, left, right. We're now just going to kind of sketch it in. Okay? And I'll show you where we go from there. But that's the fundamental rectangle I was talking about. Now we can add in the asymptotes. That's why you need the rectangle. The asymptotes always go from corner to corner. So if I put that in, there's one asymptote, and the other diagonal would be the other one. I missed the corner, but you get the idea. And now if I drew in the two parabolas, up and down or left and right? What did we say at the beginning? Up and down. Okay? The vertex is right on that. This is the point of the vertex right here. It's right on the actual rectangles. So the asymptotes are there to kind of guide you of how wide the parabolas will be. They're approaching those asymptotes. They got to be kind of sandwiched in between those. Same thing here. Only one thing left. What's the one thing that I didn't put in yet? C. I didn't put the focal points in yet, which hopefully, again, if you think back to a parabola, they're going to be inside the two parabolas. So in order to find that distance, as we take a look again, c squared equals a squared plus b squared. Which one in my equation is a squared? That's the 4. Okay. So c squared is really 4 plus the b squared is 3. So c squared equals 7, which means c is the square root of 7, which is about what? Somebody help me out on that one. 2.65? Okay. So there is your distance from the center to the foci. Okay, you go to about 2.65 in both directions. From the center of the hyperbola. So from our center point, we are going to go up 2.65, so we are somewhere in here, and we're going to go down 2.65. So somewhere in there. Okay, which again makes some sense because the parabolas should be wrapping around those foci. Okay. Like I said, what I want you to see on this one is that the process is exactly the same. Getting to this equation is the same. The center point, still the same. The A, B, and C and how you use them, that's the difference. Okay? That's the difference as you're working your way through it. Okay? Let's do another one. Just to make sure you're understanding this. One quick note, by the way. Change that last term on example 2. That should be a 62, not a 63, I think is what you have, right? Yeah, change that to a 62. Correct. On that first hour. So same thing. Let's go ahead and I'll give you a minute or two here. You can go ahead and complete the square. You can get to the equation and we'll talk about the graph then. We'll give you a heads up. You got to have a positive x squared when you complete the square. The x squared needs to be positive in order to complete the square. So there's what you should come up with. Right there. Yep, thank you. Any questions on anything up here? Yeah, Trent?
Ours is 63.
Yeah, I said change it to 62. It was a mistake. Change that to a 62. Because otherwise, if it's 63, guess what it comes out to? It comes out to 0. And you can't divide by 0 to make it equal to 1. It doesn't work out. So it was just a typo when I put it together. So it should be a 62. So on the first one, you factored out the negative 1 out of the x squared and the 2x. Okay, remember, you got it. You're always starting with x minus or x plus something is what you want to end up with. Not negative x minus something or negative x. You want x. That's why you always have to have a positive 1 for coefficients on x squared and y squared. So that you end up with x plus something or minus something and y plus or minus something. So at this point, I don't really need to divide by 1 because it's already 1. okay? But I do need to turn this in so that we have fractions. So if you think about it, if I divided everything by 1, this is really over 1, right? So now it's a little bit closer. This would be over 1, but then I'm going to fix it right away. This is why I went over problem number 3 from the assignment. Because in this case, the 16 doesn't go into 1. We can't divide that. But we can get rid of it and turn this into 1/16. Okay? Because dividing by 1/16 is the same thing as multiplying by 16, by the reciprocal. Okay? So that's the same thing. And now we're more into what we actually deal with here, what we actually have. Okay? Now we've got the equation of a hyperbola. So now, in this case, what's h and k? Let's start there. Okay, yeah. H is 1, k is -2. There's your center point, excuse me. 1 and -2. Okay, so there's the center of your hyperbola. First question, which way is this opening? Up and down, left or right? Up and down on this one. Because the y's are positive. Okay? So even though, and that's why I said you got to be careful. Yesterday we said the a's were always the bigger number. This one you got to just be careful. You got to look for the positive. Okay? And so whichever term is positive, that's the direction that it's opening. So it is going to open up and down, which means if a squared is 1/16, what's a? 1/4. We take the square root of both. Take the square root of that. That means a is 1/4. Okay. And so in this case, because we're opening up and down, we go up and down 1/4, basically, from there. So we'd be going to be pretty tight on this one. Which is why, part of the reason why, by the way, why on your assignment, I didn't give you graph paper, because sometimes it's like this, where it's really tight. You can stretch it out and just change the numbers a little bit. You can sketch it a little bit better. How about B? What's the value of B? 1. Yep. So B is 1, which means we're going to go in the other direction. So from our center point, we're going to go over 1, left and right 1. We can now put the box in. That's what A and B get you the box, so you can then put the asymptotes, and you can basically sketch everything from there. Okay. Now I can put those asymptotes in, and then we can sketch the parabola. Which way do we say the parabolas are opening? Up and down or left and right? Up and down, because the y's are the positive term. So in this case, because the box is actually stretched horizontally, what that does to the parabolas is it widens them out a little bit. That's the effect it has on the graph. So it takes this and now there are the hyperbolas. And then the last part is we still need to figure out where are the focal points, where are the foci. And again, that comes from c squared equaling a squared plus b squared. And in this case, it doesn't even really, you should know which one's a and b, but it doesn't really matter because you're adding them together anyway. But remember we said the a value is the one that was with the positive term. So technically, this is 1/16 plus 1. If we add those together, what do I get? 17/16. Think of 1 as 16/16. Plus 1 more. So you get a total of 17/16, which then we take the square root of. And what do we get? 1.03. So C is approximately 1.03. Okay, there's your value of C right there. That's from the center point to the foci. That's your distance. So we go 1.03. Let's put one there. Let's put one about right here. And there's your graph. Okay. How are we doing? Any questions?
Great.
Last thing I want you to try. Try this next one on your own. Just try it. Okay? There's no tricks or anything. It's just a practice problem. Try this last one before I give you the assignment. Matter of fact, while you're doing that, I'm going to give you the assignment so that you have it.
Quite remember having sex with our third teacher. And I was like, this is so fun. And then I got home and like whatever I was doing, and she was like, do you have any more math? And then I was like, no. So then I just sent her what we learned.
More to do.
And then a practice one. I was gonna ask for another sheet, but I won't see her until like 9 o'clock tonight.
And guess what we're doing tomorrow? Putting it all together.
Oh boy, that means it's gonna get all hard and stuff.
There's nothing new. It's just, is this an ellipse? Is it? You just got to then filter through things.
Right now.
There's no new material tomorrow.
Well, then it's tomorrow, think of it right.
See if you have any questions. Here's some problems. Work on them.
So, work day tomorrow.
Pretty much.
So exciting. B is 1. So it is 1, guys. So it's over 1, but it is 1. B is 1.
1. Is yours 1? 3 is 1. I just know you're usually like not. You know, not quite as very.
Yeah.
Then what do I do?
Oh, wait a minute. Making this harder than I did in 9th grade.
You divide by then what do I do? And then it would be so let's get that. It's square root of 10. It's square root of 10.
Because your H and K are the same. But Y is K.
We're doing it because
Yeah, like we would, but.
we have it easy way out there.
What did I put? And then B is A.
There's at least the equation if you wanted to check your equation. Here's what you should have come up with.
So where did I go wrong here? Oh, I see where I went wrong. Wait, so now.
Now I'm stuck. I got the equation. No. They're not just. That's not what's happening. That's a horrible. It's because. Or 50-year-olds. Baseball is so hard.
It goes.
Like, it's so hard. No, I could literally go to medical school and graduate and get a PhD in between.
Right there.
Well, mathematician already.
And it's so kind of world record. 130.
I could cure cancer.
That's crazy. You didn't somehow do it.
All right, let's take a look. Just come back together here real quick and wrap this up. Like I said, here's your equation that you should have ended up with, which means your center point is at negative 3, 5. We can start with that. That's the center of this hyperbola. So there's that point, negative 3, 5. In this case, are the parabolas opening up and down, left or right? Because the x term is the positive one, they're opening left and right. They're opening in the horizontal direction, which means the 1/9 is the a squared. Okay, the a squared is always the same direction as the way it opens. So square root of that is 1/3. So that means we're going 1/3 to the left and 1/3 to the right. That means b squared is 1, so we are going up 1 and down 1 from the center. And again, this is one of the reasons why I didn't give you graph paper on the actual assignment, because as you can see, we're trying to fit things in a very small area here, whereas on the actual assignment, you can sketch it so it's a little bit bigger if you need to. So, there's the box right there. There's the rectangle, which means now we can put in our asymptotes. And remind me again, which way is this opening? Left and right, because that's the positive term. And finally, the only thing left, we need to find what's our value of c. What distance do we do to get to the center? So again, one quick heads up again as well. This is just a simple place where you could make a mistake. Just giving you a heads up in advance. Be careful whether you're doing a squared plus b squared or a squared minus b squared. Okay? Yesterday, the reason I say that is yesterday as I was helping a few students, some students yesterday were accidentally adding them rather than subtracting. So just think about it real quickly before you actually go through and write it down. Try not to make that little mistake. So in this case, we've got c squared equal to 1/9 plus 1. So c squared is equal to what?
1 point, wait,
Oh, hang on. 0. So first, this is 10/9. That's what I was getting at. 9/9 plus 1/9 gives you 10/9. And the square root of that is what?
1 point.
Okay, we'll go 1.05. That works. And once again, then we just go 1 point a little bit and 1 point a little bit. Okay? All right. Like I said, just getting used to the hyperbolas and graphing them and what everything means. A little bit of difference, but the process is still the same. You got 3 questions on the assignment for today. Okay? Hang on 1 second.